Hi everybody, this is Sam with Python Basics, and in today's video we're going to be looking at finding a subarray inside an array that its sum is greater than or equal to s, but we're going to find the smallest, so not the first, but the actual smallest length subarray. So alright. So if you're new here, thanks for joining us. This is what we do. We do micro videos and topics, and we're just going to go ahead and knock out this very common interview question. And the way that I'm going to attack this is we're really going to be focused on how much cost this is going to take, how much time. Because if you've watched other videos, you see that they run len on the array. Well, that has a cost to it. So we're gonna do this. We're gonna run through this with a for loop. So all right. So we're gonna have s and our array, and we're gonna start out with the array, the sum being 5, and we're gonna adjust this. But all right. So let's get started. So we need a lot of variables and a lot of checks. So well, let's start with visualizing this. So this is actually going to be our array right here. So the way that I'm attacking this is we're going to move through and we're going to have so we have our subarray right here. So first we're going to start and it's going to be 1. And then we're going to continue, and as long as the sum or the total, we could do this a variety of ways, but we're just going to use sum right now. And once you get the hang of it, you can literally go and actually do the math yourself, so you're not doing any extra calculations. So all right, let's get this over here the same. So first is we're going to test, and we're checking against 5, correct? So we're checking against 5. So some of this is, of course, 1. So then we're going to move over here, then we're going to add 2 to our array. Let's bring this and keep it the same size. So then that's, of course, still less. Then we're going to add another 1. So we're at 4 right now. And then we're going to come, so this is going to be our start, and then we're going to have to do a little bit of math right here. So all right, now we're going to have some sort of decision, because now we have something that's greater, so we're going to need to do something. So right now, so this goes from 4 to 7. So now we're going to have, so now this is greater than s, so we're going to need to do something. We're going to move over this window. So now we delete. So now we're going to have to figure out a way to delete this and move this pointer. So then we're sitting here at, okay, so now this is greater than or equal, and then as this, and we're also going to have a starting point of infinity. And then we're going to make it smaller. So each time, because we want to check and see how small this can get as we're moving and still checking against. So all right, so right now this is 6, so this is greater than 5. So we could literally delete one more, and then all right, so then we check again. Okay, this is now less than 5. So then we need to add back. Okay, now we're at 8. Okay, so we move this. Now we move, okay, so that 8 was greater than 5, right? So we need to delete the first one. Okay, 7 is greater than 5, so we need to delete this. Okay. No, now it fails again. So then now I add, and then we deleted our 3. So now I am at 4 and 1, which happens to be 5, and this is a len of 2. So all right, I know this is very challenging, but we can, and then we just continue on. Then we come over here and we add 2. Well, then that's 7. So then we move over here and continue on. So once you really see what we're doing, but I want you to, we're using this as we're moving through the for loop. So we're going to have a linear example. And then as we're moving, we're going to increment our start. And then when we have a situation where we have a fail, we're going to move our endpoint as we go through. So, all right. So let's just go ahead and lay all this out. So we have our start point. We have our end point. Then we need our size. And like I said, this is just our example that we can see. What happens if you have a len of 1 million data points? Or 1 billion. You don't know. So this is why you set this to, we talked about this, infinity, if I can type today. So you do not know how big this is and you want to capture everything. So you make it infinity. So 14,975 billion, blah, 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 that is less than infinity. So if that happens, you get your sum and then that becomes your new size. So now what we're going to have is we're going to have our sub loc. So we're going to need to be able to spit out the array because people are going to want to see it. You're going to want to test it. So all right, now this is where it gets interesting. Now we're going to have a temp size, temporary size that we're checking. And then we're going to compare that to size. Is temp size smaller than size? All right, temp size is 0. And then there we go. So then we're going to create a sub of a list. All right, is that all our variables? That is all of our variables. So now we're going to be going through for I in our array. All right. So we're automatically, start is 0. So then if we want to capture this, how do we do this with end 0? 0, 1. So we need to increment 1 at first. All right, I'll say that again. So if we want to capture a slice and get index 0, we need to do start 0, end 0, right? So I know that this is going to be weird, but we're going to flip this at the end. And there is a method to my madness. So all right. So we're going to append I to our subarray. Then, so we're not running anything. We're going to cheat a little bit with sum. That doesn't cost a lot, but also we could make a temporary variable, and I'll show you where you could do that and delete it later. All right. So let's see. So then temp size, it's going to increment up 1 because we just added something to our array. All right, so it's being added right now. Now, there's 2 decisions. It's kind of like what we did with rock, paper, scissors. Is it less than S or is it not? So we're going to grab that right now. So sum sub less than S. We're just going to straight up continue. We don't need to do anything else because then, so as we're going through, we're slicing, we're summing, we're checking. So the first time through, 1, then 2. Okay, so we don't even need to do any other decisions. So we're just flying straight back up here. Then we get up here, and then we're 6. Oh, okay. So now we need to make some sort of decisions. Now, we're here and we get to 6. Well, I need to figure out a way, because what happens if we had a whole bunch of 1s right here and we got a 5? Well, it would be 4 all the way through, and then I got to another 4. Well, I would need to remove all of these 1s to come down here and test. So this is where a while loop is a perfect scenario. So sub while the sum of sub is greater than s, we're then going to kick out and use pop of the first. Let's come over here. Remember how we came through and we were moving down? So as we have this, we have 1, 2, 6. Well, we need to remove this. And we need, like I said before, what happens if we had a whole bunch of ones right here and then we automatically went from 4 to 9? Well, we would need to remove all the subsequent leading ones. And this is what we do right here. And then, as we're removing objects from our subarray, we need to then change size minus equals 1. And then we need to move the endpoint over 1, right? So as we're spitting out, we're moving over. As we're kicking out of the subarray, we're moving over our endpoint one at a time through this loop. So, all right. Now each time through, we need to do a test. If sum sub equals, or excuse me, is greater than or equal to s. Now, we will have an issue. There is a bug here, but we're just finding the smallest. So you could have a mixture of the smallest and it be a little bit bigger. So you could actually, that would actually be a good assignment for you to have. All right, let's bring this up here so we can see. Was that in the way? Okay. There. I didn't check. That's the first time I checked. All right. All right. So we are right here. Then if temp size is less than size, so here's our test. So now as we've kicked these out and is our new subarray that happens to still be larger than s, if it is smaller than the last subarray, we need to then replace it. So then we go size equals temp size. Now, if that is true, we also then want to log the endpoint and start point. Now, this is where we're going to flip it. So we called this start and end. Now, we created a sublocation, so we're going to have a start and an endpoint. So we're going to flip these. Sublocation equals end and start. So we're going to be used to this because now we're going to pull. Now we're going to pull this, and I'm going to copy this. And I'll show you what I did here. All right. So now there's array. Then I have this subarray. I could come down here and change this. Actually, yeah, let's do that. Start equals, there we go. So we've neatened this up. So we've flipped this around because we called this start. And now you may want to call this, well, I'm moving the endpoint over as we're going through, and I'm moving the start when we go. But I was already knee deep in this situation. So now let's go ahead and run this. So right now we have 5, right? All right, so I've added a comma here, took out these. I should have neatened this up before, but I was just running through. So all right. So now here's the length. That's the sum, and here is our location right here. So if I go through and I start changing this, and you could also then spit out what the index locations are. So now we have 4 and 2. Let's go up 7. Then we have 1, 4, 2, length of 3, 7, 8. Then we have 4, 2, 3, length of 3, and that's 8. So see, here is the bug. And you could go ahead and go in and fix this. So that's 9. Then let's do 9. Should be the exact same. Then I get 10. And then here we go. 1, 4, 2, 3. 1, 4, 2, 3. And so on. So this is the algorithm. What I've found is the most cost effective. So you're only going through this once. And like I said before, you could actually add a total. Where did I have that? Where you could do this without any extra. Do I have it right here after temp size? You could do a total increment up 1 I, and let's do total equals 0, and then down here, then I think what I did is TTL minus the pop, and then you could go through just like so and then print out. So you could see this each time through. Let's go ahead and add this so you can really see. Print TTL. So as you could go, you could see it 10, 10, 8, and then it captured. Yeah, let's look at 5. So 5, 2, 5, 4, 3 as it moves through, and then it locks in what the smallest was, because it hit here and then again here. That's the bug. Here is it hits it twice, but it just does the first one. So you could tweak this a lot, but I just wanted to share this with you. This is a great interview question, if you can see. There we go. But great question. And I realized that I hadn't gotten to it yet. But as always, guys, thank you so much for watching. Stay tuned, and we'll see you next time. Bye, guys. Hey, guys. Thanks for joining us today. I hope you really enjoyed today's video. And if you haven't, check out this video right here or this one right down here. And most important, make sure you're hitting this subscribe button and the notification bell. Thanks again for joining us, and we hope to see you next time. Bye, guys.